Hello friends, myself R.D. Mahajan presenting my one more video on Maclaurin's theorem. Prove that e raised to x cos alpha multiplied by cos of x sin alpha is equals to 1 plus x cos alpha plus x square by 2 factorial into cos of 2 alpha and so on. If you observe the terms on the right hand side, it is in terms of increasing powers of x, and as it is in terms of increasing powers of x, it becomes a problem of Maclaurin's theorem. Therefore, we take the help of here given. We consider that as y e raised to x cos alpha into cos of x sin alpha as equation 1, and then we know the one standard result from nth order derivative. We know that if y is equal to e raised to ax multiplied by, then its nth derivative yn is given by r raised to n into e raised to ax cos of bx plus c plus n phi, where the value of r is given by root of a square plus b square and phi as tan inverse of b by e. This is the standard result to find out nth derivative of that term, which is in the form y is equal to e raised to x into cos of. Therefore, compare this with this, we get the value of a. Comparing these two terms, we get a as a coefficient of x. Here, coefficient of x is cos alpha. Therefore, a is equal to cos alpha, and b is the coefficient of x in this term of cos, and therefore here the coefficient of x is sin alpha. Therefore, we try to find out the value of r as root of a square plus b square. It is cos square alpha plus sin square alpha, and cos square plus sin square is nothing but 1. Therefore, root of 1 is 1, and we get second phi is equal to tan inverse of b by e. B is here sin alpha and divided by e cos alpha. It is tan inverse of tan alpha. And therefore we get phi is equals to alpha. Nth derivative by applying this result, therefore we get yn is equals to nth derivative of equation 1 as r raised to n. R is here 1 raised to n multiplied by e raised to x. It is e raised to x cos alpha into cos of bx plus c cos of x sin alpha plus n phi. Phi is alpha, and therefore we get yn is equal to e raised to x cos alpha cos of x sin alpha plus n alpha. We call this as equation number 2. In 1 and 2 we get, therefore if we put x is equals to 0, we get the value of y at 0 as e raised to 0 when x is 0, and cos of 0, cos 0 is 1, e raised to 0 is also 1. 1 into 1 we get that value as 1. And second, nth derivative of y at x is equals to 0 as, if we put x is equals to 0 here, we get e raised to 0 once again, and cos of x at 0, that term becomes 0, plus n alpha. Therefore, we get y at 0 as cos of n alpha. And then in this result, we put n is equals to 1, 2, 3, so on. Put n is equals to 1, 2, 3, and so on to get values of derivative, successive derivatives at x is equals to 0. Therefore, we get substitute n equals to 1, we get y1 at 0 as cos of n alpha, n is equals to 1. Therefore, we get cos alpha. Next, y2 at 0, for n is equals to 2, we get cos of 2 alpha. For n is equal to 3, we get y3 at 0 as cos of 3 alpha, and so on. And then applying Maclaurin's theorem, get y is equal to y at 0 plus x into y1 at 0 plus x square by 2 factorial, y2 at 0, and so on. Y is that given function as e raised to x cos alpha into cos of x sin alpha as equals to y0, the value of y0 is 1, plus x into y1 at 0, the value of y1 at 0 is cos alpha. Next one is x square by 2 factorial, y2 at 0, y2 at 0 is cos of 2 alpha, and so on. We get the required result. First term is 1, next x cos alpha, yes, we are getting it, and third x square by 2 factorial into cos of 2 alpha, and so on. We get the required result. Hence proved. One more I will discuss in my next video. If you like my video, please share it, as well as subscribe to my channel if you are not subscribed yet. Also press the bell icon to receive the notification for my new videos. Thank you.